So hi guys, mayong adlaw. Welcome to NatzMath TV. So in this video, I will be presenting to you about addition and subtraction of rational algebraic expressions with different denominators, or that is also called dissimilar fractions. So we will start the discussion after this intro. So addition and subtraction of rational algebraic expressions. So how do we add and subtract rational algebraic expressions with different denominators or dissimilar fractions? So we go directly to our examples. So let's proceed to our example number 1. We are given these rational algebraic expressions. The first fraction, 2 over 2x plus 4 minus 5x over x squared plus 2x. So in addition and subtraction of rational algebraic expressions, just like in the previous video that I had presented to you, we need to find the least common denominator, or the LCD. So we have here the two denominators, 2x plus 4 and x squared plus 2x. So what is the LCD in these denominators? So in my previous video, I had presented to you about the steps in finding the least common denominator of our rational algebraic expressions. It says here, the first step is to factor out the denominators completely. So as you can see, in the first denominator, we have 2x plus 4. We have a binomial. So what we need to do is to factor out this binomial, so we copy the numerator 2, and the denominator, we factor out the common monomial factor in this binomial, and a common monomial factor is 2. We factor out the 2, and what shall remain inside the parentheses shall be the x plus 2. Because when we multiply these 2 to the terms inside the parentheses, that is 2 times x, that will give us 2x, and 2 times 2, that will give us 4. Common monomial factor in this binomial is 2. Our factors for this binomial shall be 2 times x plus 2. Now proceeding to the next denominator, we have x squared plus 2x. So the same thing happens. We factor out the common monomial factor in this binomial, and the common is x. So we factor out the x. What shall remain inside the parentheses shall be x plus 2. We have here x squared plus 2x. So we factor out the x. We distribute this x to the terms inside the parentheses, that is x times x, that will give us x squared, and x times 2, that will give us 2x. So these are the factors of this binomial. So this is our first denominator, and this is our second denominator. Now proceeding to the second step, list all the factors that appear in the denominators. If the factor appears more than once, we list down the highest power. In this case, we have the factors 2, x plus 2, x, and x plus 2. As you have observed, we have 2 as the factor and x as the factor, which are different factors. But we have here two factors that are the same, that is x plus 2 and x plus 2. And we need to list down only one of the factors. So therefore, our LCD for these fractions is 2x times x plus 2. We have here 2 as the first factor, and we have here the x as the second factor, and we list down one of these factors. Do not list down both. We only list down one. So that is x plus 2. So this is our LCD. 2x times x plus 2. So how do we perform now the operation? So this is our LCD. We divide this LCD by the first denominator. So that is 2x times x plus 2 divided by 2 times x plus 2. So that would be 2x times x plus 2, this one here, divided by 2 times x plus 2, which is this denominator. So what shall we do here is to cancel out 2, since they are the same factor, and also x plus 2. So what remains is the x. So if we are going to divide 2x times x plus 2 divided by 2 times x plus 2, what shall remain is the x. Then afterwards, after dividing, we multiply the quotient by the numerator. So therefore, we have here x multiplied to 2, and that's why we have here 2x. Then we copy minus. The same process in the second denominator. We have the LCD divided by the second denominator. So we will have here 2x times x plus 2, which is the LCD, divided by the second denominator, which is x times x plus 2. The same process, we cancel out the common factor. We cancel out the x in the numerator and denominator, and of course the x plus 2. So what remains is 2. So we multiply this 2 to the numerator, which is 5x. So that is 2 times 5x, we have 10x. Then afterwards, we focus our attention to the numerator. This is now 2x minus 10x. Since 2x and 10x are like terms, they have the same variable and the same exponent, so they are like terms, so we can combine these two terms. So 2x minus 10x will give us negative 8x. So we copy the denominator or the LCD, 2x times x plus 2. Then afterwards, we simplify this fraction. We divide negative 8 divided by 2, and since we have x and x here, this is x and x, we can cancel out the x. Then we divide negative 8 divided by 2, that would give us negative 4. So that is negative 4 over x plus 2. So this is now our final answer. Now let's proceed to our second example. Example number 2, we are given this rational algebraic expression, x plus 1 over 2 minus x minus 2 over 3 plus 2x minus 1 over 9. Now as you can see, we have here the first denominator, which is 2. We follow the same step. Our first denominator is 2. Our second denominator is 3. Both the first and the second denominator are prime numbers, meaning they do not have any other factors except 1. That is 2 times 1 and 3 times 1. So there is no need for us to factor out 2 and 3. But the third denominator, that is 9. So we can factor out 9 by using 3 times 3. So the fraction shall become, we copy the first fraction x plus 1 over 2 because we cannot factor out 2 anymore. We copy minus, and of course we copy the second fraction, which is x minus 2 over 3. Then the third fraction, that is 2x minus 1. Then we factor out 9, that is 3 times 3, which is 9, or we can write 3 times 3 as 3 squared, or that is 9. Then afterwards, we list down all factors that appears in the denominator, but on this case, we have the common factor, which is 3 and 3. And it says here that we have to list down only the factor having the highest exponent. In this case, we have 3 squared. So we do not list down 3. And we have another factor, which is 2. So therefore, our LCD for these denominators is 18. Why? Because we have here 2 and 3 squared. 3 squared is 9. 9 times 2 is 18. As I've said, we only consider the factor having the highest exponent, that is 3 squared, and the other factor, which is 2. Again, we do not list down 3 because they are similar to these factors here. So our LCD is 18. Now this time, the same process, we divide the LCD by the denominators. So that is 18 divided by 2, that will give us 9. Then we multiply that with the numerator, which is x plus 1. That's why we have here 9 times x plus 1. Then we copy the minus. This minus here, we copy the minus here. Then next, in the second denominator, we have 18 divided by 3, that is 6. That's why we have here 6. And we multiply that with the numerator, which is x minus 2. Then we copy plus. We have here the plus. Then 18 divided by 9. 3 squared is 9. So 18 divided by 9 will give us 2. So therefore, we have here the 2. Then we multiply that with the numerator, which is 2x minus 1. Then afterwards, we distribute 9 to the terms inside the parentheses. The same also with negative 6. The same also with 2. So this will become 9 times x will give us 9x. 9 times 1 will give us 9. Then next is negative 6 times x will give us negative 6x. Then negative 6 times negative 2 will give us positive 12. Then next we have positive 2 times 2x will give us 4x. Then 2 times negative 1 will give us negative 2. This time, we combine like terms. We have here 9x, 6x, and 4x. They are like terms because they have the same variable and the same exponent. So we can combine 9x minus 6x plus 4x. So that will give us 7x. 9x minus 6x is 3x plus 4x will give us 7x. The same happens for the constants. We have here 9 plus 12 minus 2. So that is 9 plus 12 is 21, minus 2 is 19. Then we copy the LCD, which is 18. Now since 7x plus 19 is not factorable anymore, and there are no more common factors in the numerator and denominator, so therefore this is now our final answer. Next example. Example number 3. We are given these fractions. 1 over a plus 3 over a squared b minus 4 over b. In this example, we have here a, which has no other factors except 1, that is a times 1 will give us a. Also, we have b, which has no other factor, which is b times 1, so there is no need for us to factor out b. But we have here a squared and b squared, so we have the factors a and b. But we have the highest exponent here, which is a squared, and we have two common factors b and b. So what is our LCD therefore? Our LCD shall be a squared b. As I've said in my previous examples, we are only going to list down those factors having the highest exponent. In this case, our highest exponent is 2. That's why we only list down a squared. But since we have b and b here, we have the same factors b and b. We only list down 1. That's why we have here the b. So our LCD is a squared b. The same process, we divide a squared, our LCD, by the first denominator, which is a. So a squared b divided by a. That is a squared b divided by a. So since a squared divided by a is a, because the a squared can be factored out as a times a. And we have a in the denominator, so we can cancel out 1a in the numerator. So what shall remain is a. And the remaining factor, which is b. So if we are going to divide a squared b divided by a, will give us ab. So therefore, ab times 1, again, a squared b divided by a is ab times 1 in the numerator will give us ab. Then, the same process in the second denominator. So we have a squared b, which is the LCD, divided by the second denominator, which is also a squared b. So this is cancelled out, and the result is 1. Then 1 multiplied to the numerator, which is 3, of course, will give us 3. Then we copy minus. The same process, a squared b divided by the b here. So in this case, we can cancel out the b, the same factor b in the numerator and denominator. So what remains is a squared. So a squared times 4 will give us 4a squared. Now, since the numerator in this fraction is not factorable anymore, there is no common factors already. So what shall we do? We can consider this one as our final answer, or we can arrange this one as negative 4a squared plus ab plus 3 over a squared b. So this is our final answer, or this answer is acceptable. So proceed to example number 4, our last example. So we are given 3x over 2x minus 3 minus 2x over 2x plus 3 plus 3 over 4x squared minus 9. Now, as you can see in the first denominator, that is 2x minus 3. 2x minus 3 is not factorable anymore. So, meaning, there's no other factors of 2x minus 3 except 1. So, we cannot factor out 2x minus 3. The same also with 2x plus 3. But in the third denominator, which is 4x squared minus 9, this is sum and difference of squares. So we can factor this out. We can have 2x minus 3 times 2x plus 3. So we have these factors, 2x minus 3 2x plus 3, and we have also 2x minus 3 times x plus 3. So we have the same factors, 2x minus 3 and 2x plus 3. So therefore, our LCD shall be 2x minus 3 times 2x plus 3. We only list down one factors if they have the same factors. Now, what we need to do is to divide the LCD by the denominators. So, 2x minus 3 times 2x plus 3 divided by 2x minus 3 will give us 2x plus 3. Then, we multiplied the result with the numerator. So, we have here 2x times 2x plus 3. Then, we copy minus. So, 2x minus 3, the same process, 2x minus 3 divided by 2x plus 3 will give us 2x minus 3. So, we multiply this one with the numerator, which is 2x. So, we have negative 2x or minus 2x times 2x minus 3. Then, we copy plus. If we are going to divide the LCD by the third denominator, since they are the same, so we can cancel out, this shall result to 1. Then 1 multiplied to 3 will give us 3. Then this time we distribute 3x to the terms inside the parentheses, so that shall become 3x times 2x will give us 6x squared. Then 3x times 3 will give us 9x. Then the same with negative 2x times 2x will give us negative 4x squared. Then multiply negative 2x times negative 3 will give us positive 6x, and we copy positive 3. Then afterwards, we combine like terms. We have here 6x squared and negative 4x squared. The same variable, the same exponent, so they are like terms. We can combine this one. 6x squared minus 4x squared will give us 2x squared. Another like terms, we have 9x plus 6x. So 9x plus 6x will give us 15x. And of course, we simply copy positive 3. And since the numerator 2x squared plus 15x plus 3 is not factorable anymore, so this shall be our final answer. Okay, so that's it. I hope you have learned something from this video. Please do not forget to subscribe, like, and share to your friends, especially those who are grade 9 students, because this topic is for grade 9 students. So for now, thank you and God bless.